This is part 1 of 5.5, solving problems using quadratic relations. Our goal today is to learn how to solve practical real-world problems using quadratic relations. Specifically, we're going to model and solve problems using the vertex form of a quadratic relation. And so many of the problems will ask us for what is the maximum you could get, what is the minimum you can get, what is the maximum height, what is the minimum height, so on and so forth, or at what point will we reach the maximum height, so on and so forth. So the main idea I want you to get is that the y-coordinate of the vertex, is going to be the maximum or the minimum value. And you already know that from some of the problems we've done in previous notes. So y-coordinate of the vertex is the maximum or minimum value. So for example, over here, in this parabola that opens from the bottom, we would have a negative a. Our vertex is hk. And you know that the maximum value reached by the parabola, the vertical value, is k, which is max y, because there's nothing higher than that y. As you can see, everything here is below this y, and everything on this side is below the y as well. Whereas if it was a minimum value, same idea, we have hk, just the parabola is opening from the top. You'll notice that the k is the lowest y value in this situation here, because there's nothing that goes lower than it. Everything over here is higher in terms of y, everything over here is higher in terms of y as well. Sometimes you might not be given the vertex form right away, and at this point you don't know how to go from standard to vertex. What you do know is how to go from standard to the factored form. So if you can go from standard to factored form, you can actually find the vertex, and you can find the vertex form as a result. Once you go to the from standard to the factored form, you know that your vertex is in between your zeros. So if you had a parabola like this, for example, your zeros are over here. That would be the s and the r values. You know that the vertex has to be in between. So to find the x value of your vertex, all you have to do is take your zeros, add them together, divide by 2 to find the middle. So for example, if this was 2 and this was 6 over here, you would do 2 plus 6 and then divide by 2, and that would give you 8 divided by 2, which would give you 4. The x value here would be 4, and then you can plug this x value into your equation over here to find the y value, and then that way you can get your k, and you'll have your hk. Once you have your hk, then you can plug your h into the vertex form over here, your k into the vertex form over here, and of course you would have your a over here, which you could plug over here. So once you have the hk from the factored form doing this process here, you can then plug in your a, h, and k into the vertex form, and that'll allow you to solve problems where we're asking you for maximum, minimum, so on and so forth. So the first problem we're going to do is example number 1. You do have the solutions posted online. I'm going to do a slightly different method than your solution posted online, because I want you to get those different ways to do it, but they're all pretty much equivalent to each other. You'll get the same conclusion in the end. And what I need you to get about these problems is that they will take you some time. You need to really sit down and read it a little bit and understand what's going on to visualize it. If you don't do a drawing, if you don't sketch something, it's going to be very difficult to do. So the underside of a concrete railway underpass forms a parabolic arch. So it's kind of like if you're going, I'm going to do a brief sketch here. If you're driving in a car, or if your parents are driving, and you're going under a bridge, we have a parabolic arch over here. This part here is the parabola. The arch is 30 meters wide at its base, 10.8 centimeters high in concrete, and the upper surface of the underpass is 40 meters wide. So this whole part over here is 40 meters. The concrete is 2 meters thick at its center, so 2 meters over here. Can a truck that is 5 meters wide and 7.5 meters tall get through the underpass? So what we're asking is, if there's a truck with those dimensions, can it fit through this underpass here? And so we're going to do a drawing and figure out if that is possible. We have a lot of information given to us here. And let's just see what we can figure out. So first of all, I'm going to do more of a grid drawing of the parabolic arch. So here's my grid. I'll draw my parabola. Notice I'm starting the parabola from the origin. You don't have to do that. I am. What matters is that you have the right dimensions. So I'm starting the parabola with one end at the origin here. So that'll be 0, 0. I'm then going to make my other 0 30, because we know it's 30 meters wide at the base. So it'll be 30, 0. And we know that the highest point is going to be in the middle for the parabola, so between 0 and 30. If you don't know what that is, all you have to do to find the midpoint is simply do your two zeros, your x values for your two zeros, 30 plus 0, divided by 2, and that'll give you the in-between. And so it'll be 15. So at 15 meters is where you have your highest point. So at about here, 15, you have your highest point for the arch, and it's going to be 10.8. 10.8. So I'm just going to draw that up here. This part here is 10.8. So here we've drawn the arch part. I haven't drawn the concrete area, but we can do that if you wanted to. So you know the concrete area is 40 meters across. Here we have 30 meters wide at the base. So what that means is if I extend it a little bit on this side, I have to be 10 wider overall than the parabolic arch. So basically 5 on both sides. So I'd be starting at negative 5, 0 over here. I'm not really going to use these points right now. I'm just showing how I would do a nice complete model. Negative 5, 0 here. And then it would probably end at about 35, 0 over here. And the reason is that the concrete is 40 meters wide. So it's larger than the 30 meters. I have 5 on this side plus 5 on that side. That's 10 meters more. So I'm going to do that over here, oops, like this. And you would do a better job than I would at this. This is the concrete part. And we know that the concrete is 2 meters thick at its center. So if we were looking over here, this part here would be 2 meters. So I'm just filling in the diagram just in case I need it of this information. I don't think I need all of it. And then this part here is 40 meters. So a nice complete diagram is your first step. And then you can get started on trying to solve the problem. So first, let's find an equation for our parabola. So what I would do first is, first of all, sketch. Sketch. And again, in my sketch, I decided to start the parabola at 0, 0. If you didn't, if you want to start at a different area, you could do that. You just have to account for that as you go throughout the process. In your notes, you'll see that the solution shows the parabola at a different location. And so you have to account for that different location and understand what you're doing to model it. So I sketched the parabola. Next, we're going to find an equation. So next, we're going to find an equation for the parabola. Equation. And we want to find it in its vertex form. Equation in the form y is equal to a x minus h. Don't forget the squared here. That's something we often forget when we go too fast. K. Now we have h and k. We know that h and k are 15 and 10.8. So we found that already by doing our sketch. So that's why a sketch is important, because it actually gives you a lot of information. So what we can do is we can go and plug that in. We can go write y is equal to a x minus 15 squared plus 10.8. And so all we really need to do now is find our a value. To find the a value, you just need some other point on the parabola. And we do have another point in the parabola. We have 2 points to choose from. We can do 30, 0, or 0, 0. It's really up to you. So I'll choose the point 0, 0. You could choose the point 30, 0, and you'll see you'll get the same answer. So you can try it out. So using 0, 0, I'm going to go find A. I'm going to plug my x and y of this point, and then isolate for A. So 0 is my y, is equal to A times 0 minus 15 squared plus 10.8. I'm going to simplify and then solve for A. So negative 15 squared is just 15 times 15, so that's 225. So we have 225A plus 10.8. They're equal to 0. I can remove the 10.8 from this side by subtracting or sending 10.8 to the other side, if you will. So by doing minus 10.8. And then I get minus 10.8 is equal to 225A. And I can divide both sides by 225 to get A. And you'll notice that my A value makes sense. Or at least part of it makes sense because it's negative. And our parabola opens from the bottom. So our A value is negative 0.048. Now we can go plug that into our equation, and we have a full equation here. Y is equal to negative 0.048. Open the bracket here, x minus 15 squared plus 10.8, or 10 point, yeah, 10 point, that's right. And this is our equation. So what do we do with this equation? What happens now? This is our first step, was to sketch. Second step was to find the equation of the parabola. Remember, our goal is to see if this truck can fit through. So what I'm going to do is I'm just going to erase this really quickly, this part here, so I can draw a truck in. I'm going to put a truck under the overpass. And I'm going to assume the truck is going straight through the middle. So I'm going to draw the truck here. This is the truck. Like this. And remember, the truck has dimensions. We have dimensions of 5 meters wide and 7.5 meters tall. So we want to see if the truck will fit through. We know if it's going through the middle part of the truck will go through just fine, but look at the sides here. Will these edges be low enough to go through the lower parts of the parabola? In my picture it looks like it, but I drew a picture as a sketch. I didn't have appropriate numbers in yet. So I need to figure out if at these points here, at these edges, if my truck will be able to clear this parabola. Will the points at the edges here and here on the parabola be higher than the points at the edges of the truck? And so to figure that out, I need to find what are these x values of the truck edges. So remember, the truck is 2.5 meters. Assuming it's going through the middle there, 5 meters over here, assuming it's going through the middle, the truck is 5 meters here, that means there should be 2.5 meters on both sides. 2.5 meters here and here. If it was 6, it would have been 3 and 3. So what x value does that correspond to? Well, this in the middle is 15. So the left side, the x value would be 15 minus 2.5. So that would be 12.5. And on the right side, it would be 15 plus 2.5. So 17.5. So what we need to do is see if at these x values, what is the height of the parabola? Is it lower or higher than the truck? And so in the next video, we're going to continue this problem.